Topic 2. Kinematics of linear motion. Hi everyone, today we are going to discuss the definition of instantaneous velocity, average velocity and uniform velocity. Can you recall what is linear motion? Linear motion is motion of an object along a straight line path.
Let's remind all of you what velocity is.
What velocity is? It's speed with direction, and it's hence a vector quantity.
Velocity also tells us how fast the object is moving and the direction of its moving. In other words, velocity can be defined as the rate of change of displacement. The mathematical expression for velocity is displacement over time travel, or s over t. Velocity is a vector quantity and its SI unit is ms1. There are three types of velocities. First, instantaneous velocity. Second, average velocity. And third, uniform velocity. Instantaneous velocity. Instantaneous velocity is the velocity of a body at a particular instant. It is also commonly referred as velocity at point A or velocity at time, t. Mathematically, instantaneous velocity is defined as limits of delta s over delta t when delta t approaching 0. That is when we consider a very short time interval such that delta s over delta t became ds over dt, which is the differentiation of displacement with time.
Instantaneous velocity can simply be understood as the gradient of displacement versus time graph, as can be seen in this graph. Since instantaneous velocity happens at particular time, therefore, gradient of a tangent line to the curve at a specific time is the instantaneous velocity.
Let's look at this video to further understand the situation.
Pretend you were a physics student. You were just getting out of class. You were walking home when you remembered that there was a Galaxy Wars marathon on tonight. So you'd do what every physics student would do: run. You're pretty motivated to get home, so say you start running at 6 meters per second. Maybe it's been a while since the last time you ran, so you have to slow down a little bit to 2 meters per second. When you get a little closer to home, you say, "No, Captain Antares wouldn't give up, and I'm not giving up either," and you start running at 8 meters per second, and you make it home just in time for the opening music. These numbers are values of the instantaneous speed. The instantaneous speed is the speed of an object at a particular moment in time. And if you include the direction with that speed, you get the instantaneous velocity. In other words, 8 meters per second to the right was the instantaneous velocity of this person at that particular moment.
Average velocity. Average velocity is defined as the rate of change of displacement. Mathematically, average velocity is the change of displacement over time interval. The direction of velocity is in the same direction as change in displacement. Since average velocity involved 2 points on the displacement against time graph, hence the slope of the ST graph represents average velocity between 2 points, P1 and P2. Therefore, gradient of the slope equals to average velocity. Let's look at this video to further understand the situation.
Let's say you jogged 60 meters in a time of 15 seconds. During this time, you were speeding up and slowing down and changing your speed at every moment. Regardless of the speeding up or slowing down that took place during this path, your average velocity is still just going to be 4 meters per second to the right, or if you like, positive 4 meters per second.
Uniform velocity. Uniform velocity, also known as constant velocity. The magnitude of speed and direction are always same at any time. Therefore the acceleration is zero. For example, consider a bicycle starting from 0 km per hour and moving at speed of 60 km per hour on a straight road. If it covers a distance of 1 kilometer in 1 minute, we say that the body is moving with a uniform velocity.